Welcome back. In this chapter, we're going to talk about arrays, structs, and closures. So I've already made a new playground page for that. I'd like to show you a little bit more about using closures. And here's a very simple example, right? I'm going to go create a list of exam scores, an array of exam scores, right? 90, 50, and 60. And if I want to sort them, there's a nice little array method called sorted. So let sorted scores equals to scores.sorted. And I'm going to print out the sorted scores. Okay, pretty simple. What that does is it will actually sort the array for us and it will return it and put it into a separate variable, or in this case, a separate constant. Okay, don't worry too much about whether it's a variable or a constant. I just kind of chose them at random. Now, what then if you have all these scores as part of a student database? All right, and each student is represented by a struct, and the struct has a name and it has an exam score, and you have a whole array of structs. Let's try this out, right? So I have the code in my clipboard because I just thought I shouldn't type it out on the screen. Let's review it real quick. So I have a struct over here where it contains a name that's a string and an exam score that's an integer. Down here, I have an array of structs. Okay, previously we've been working with arrays of integers and arrays of strings. Now we have an array of structs. And as mentioned in one of the earlier videos, you can actually define your array over multiple lines, and it makes sense to do so here. It's a lot easier to read. Each of these is a struct with a name and an exam score. Okay, ignore my terrible naming of the students. Now, I can't just use sorted on this array. Okay, I can't just use sorted on this array. I could try, but let's see what happens, right? Sorted students equals to students.sorted. Okay, and I'm going to print out sorted students. If I try this, I have an error, right? Because it has no idea how to sort my students. Do I want to sort by name? Do I want to sort by exam score? Could be either. Do I want to sort by memory address or something like that? I have no idea, right? Says Swift. So what we can use is we can use the special function in sorted, where you give it another function that decides how these two students should be compared. Okay, that sounds a bit much, but I'm just going to type out the code and you're going to see how that works. Okay, so if I type sorted, I do open bracket, it's actually got an autocomplete that says sorted by, that says student throws bool rethrows, right? Which sounds very violent, but it just means that there's something going on with closures and things like that. And what this means is that you're passing in a function taking two students where it decides how to order these two students. Okay, so I'm going to press enter and it gives us this thing. And here, right, in theory, what you need to do is you need to write an entire closure and pass in the name of the closure over here. Okay, so I'll show you that method real quick, but you don't need to pay too much attention to that method. Just take a look at how that works, all right? And I'll show you a much easier method in about 2 minutes time. So this closure will look like this, right? Sorting closure, it's like a sorting hat. Let's call it a sorting hat, right? Sorting hat takes in two students. And it returns a bool. And there's this keyword called in, which you might see at some point in the future, right? And it says if student1.exam score greater than student2.exam score, then return true, else return false. Okay, so this is the sorting hat, right? And this sorting hat sorts students by decreasing student score. Okay, and what I can do is I can take this closure and put it inside here. Okay, that sorted students equals to students sorted by sorting hat. And I'm going to print out my sorted students. And let's take a look. Now, avocado comes first because it has the highest score, followed by chicken, followed by banana. Okay, so that's all well and good, but my goodness, what a lot of code. Okay, one of the really cool things about closures is that you don't actually need to give names to closures. Right, so you can take this entire chunk of code, cut it, goodbye sorting hat, and paste the entire thing here. Okay, I know I said this was an improvement, right? But it looks awful right now, and it still works. Okay, you're still sorting by exam scores. Okay, pretty nice. Now, what we can actually do is we can simplify this code by a lot. And I'm going to do the simple simplification first, which is the if statement over here, right? You know that from a previous video, this thing in the middle, this condition right here, right, evaluates to true and you return true, in which case you can just change this to return this, okay? And you know what? You know from the previous video too that you can get rid of the word return. Okay, so that's pretty nice, right? That actually helps cut down a lot of code and it still works. You still get the correct order of students. Let's try and simplify this a little bit more, all right? And the way I'm going to simplify it is pretty extreme. I'm going to first remove all this code and just change the student1 to be $0 and student2 to be $1. Okay, what this means is that we kind of know that this closure takes in two arguments and we know that they're both of type student because that's the type that shows up in this array. Okay, so we say, okay, let's just refer to the first one as $0 and the second one as $1. It's as though I have two people coming into my room and don't want to know what their names are. I just say, you do this and you do that. Okay, so first person is $0, second person is $1. All right, and the last optimization is probably the most important. It's called trailing closure syntax. If your function takes in a closure, you can actually remove the brackets, the round brackets, and the argument label in some cases, and just type it out like this. Okay, this is what I'd like you to pay the most attention to. This is how we are going to be writing most of our closures. All right, what's happening here is that sorted is a function. It should have some round brackets, right? But we kind of remove them in favor of just putting in curly braces with the closure that defines how it's sorted. Okay, and you know what? This is a lot like SwiftUI, right? But before we go back to SwiftUI, let me just run my code one last time to prove that it works. And I'm going to go over here and there you go. And if I change this to a less than sign, it should flip the entire order of my sorting. And I should get the 50 score followed by the 60 score followed by the 90 score. Okay, so this is fairly complex code, and I don't blame you if you need some time to digest it. What's really important is that you realize that this thing over here is a closure that is passed in as an argument to the function called sorted. Okay, that's the really important thing. And one of the other things that was pretty useful to know was the keyword called in, right? We'll come back to that later on, right, in the later chapter when we need it. But for now, just be aware of what this curly brace means. All right, for this next part, I'm going to go create a new playground page again, and I'm going to have more closures in SwiftUI. Okay, and over here, I'm going to demonstrate what a button could look like in SwiftUI. So I'm going to import SwiftUI, and I'm going to say button, open bracket, right? And this is the same set of autocomplete that you might have seen before. And the one we wanted you to use was action label, right? So if I press enter, now if you look at this, hopefully it makes a bit more sense, right? So here's a button. It takes in two closures, right? The first closure is the code to be run. Second closure is what you use to render on screen. The first closure, you could, if you press enter, right, it will make it into the nice trailing closure syntax that we've seen in the previous unit. I'm going to avoid that. I'm going to press curly brace over here, and I'm going to press curly brace over here. And now I can type out the exact closures this way. This is perfectly valid code, right? So this is print hello, and this could be a text, right, that says click me. Okay, this is perfectly valid, right? It's a button with an action and a label. The one using autocomplete looks like this, right? Not like this, it looks like this. If I press enter over here, right, then it'll be print hello also and text click me also. These two are perfectly interchangeable. Okay, they are exactly the same to Swift, and it will run exactly the same, just that the second example over here is using trailing closure syntax, right? It's got a much cleaner look, and it makes for much nicer looking code in Swift. And you know what? This is the case for even things like VStacks. Let me show you a VStack as well, right? So VStack over here, if you press open bracket, this is what a full VStack looks like. It's got some kind of alignment. You can press dot center, spacing, spacing like how far apart these are, and here's a closure, and you could type open curly brace and type in some stuff, text, hello world. Okay, and then get another text, hi, text, is anyone there? Okay, so this is what a VStack could look like, but the ones you are used to are like this: the VStack, text, hello, text, hi, text, hello. All right, these two are functionally similar, and the reason why you don't need to give this second VStack an alignment or a spacing is because this is a struct that comes with some default values. Okay, let me show you one last example of what a SwiftUI view with closures could look like. Here's a stepper. Okay, a stepper takes in 3 arguments. One of them is a string, and 2 of them are closures. So it could be stepper, more Nutella, right? So stepper is like, plus minus button. It would be great if I could show you how it works, but I can put this into your SwiftUI playground to try it out. On increment, takes in a function, and on decrement, it also takes in a function. Okay, so this is what it looks like without trailing closure syntax. With trailing closure syntax, here's what you could do. Okay, so you know what? Let me just put some print statements in here. More, print, less, sad face. Okay, a stepper, string protocol with on increment and on decrement. If I type in more Nutella over here, if I go to this and I try and do it with trailing closure syntax, I just need to press enter, and it will convert it for me. Print more, print less, sad. Okay, so just take a look at these two, right? Stare at these, let them burn into your brain a little bit. I'm not sure why, right? But it's really good to know that you can express your SwiftUI code in more than one way. And the reason for that is because they are structs that take in closures. Okay, so that's it for this entire unit. We've done a whole bunch of Swift related things that are very important for us in SwiftUI moving forward, and it's really good for your understanding in the long run as well. All right, so we've done arrays, we've done structs, and we've done closures, and I will see you soon for the next unit where we're going to make some cool app or another. Thanks very much for joining us. Please like and subscribe. Please be kind to animals. Don't eat too much Nutella, yeah, be healthy, stuff like that. Goodbye. Thanks. See you soon. Bye.